Okay, guys, so these notes are your laws of exponents. If you're printing these notes out, I'm going to be moving all over the place, so I'm not going to really go following the notes. So I'm just going to kind of focus on the highlights and what it is that you need to know so you can be ready for your test. So we're going to go ahead and start off right here. This is called the product of powers. So right here, and again, I'm not going to fill these in like they were intended to be done the first time in class. I'm going to focus just, again, I'm just going to go right to it and let you know how to do it and how to get the answer. When you're doing the product of powers, uh, when you want to do here is they have to have the same base. So if you look at this example here, notice that they both have a base of 2. Your exponents are 2 and 3. So when they have the same base and you're multiplying, and this is called product of powers, all you have to do is add the exponents. So the answer of this one would just be 2. You're going to do 2 plus 3, and that gives you 5. So as long as they have the same base, all you have to do is add their powers. So this one, they have the same base. So then I know that I can just add the 4 and the 5. So that gives you 3 to the 9th power. You just do 4 plus 9. The next example, they have the same base, so you're just going to do 6 plus 8. So it's going to be 6 plus 8 gives you 14. So it's 11 to the 14th power. You can do multiple terms. On this one, you have 3 terms. So as long as they all have the same base, you can add their powers. So you would do 3 plus 4 plus 1, which gives you 8. So this would be 5 to the 8th power. You can also have a base that's a variable. So in this case here, our variable is the base. So we would just do 7 plus 9 because they have the same base. And then that would give you x to the 16th power. So again, anytime you have product of powers, you're just going to add them. Let's see, which one should we do next? Again, I'm going to be skipping around here so that it kind of follows and makes more of a sense. So let's do power to a power. So when, and again, we're going to skip all this part right here. We're just going to really just focus in on how to get the answer. This is different because you're taking a power and taking it to another power. So if you notice here, you have 2 to the 2nd power, then you're taking that to the 3rd power. So this is what's called power to a power. So when you have that, you want to multiply those two numbers. So you're going to do 2 times 3 gives you 6. So this would be 2 to the power of 6. That's called power to a power. So like on the second example, you're going to take that 4 and you're going to multiply it to the 3. So that gives you 4 times 3 gives you 12. So it's going to be 5 to the 12th power. Again, that's power to a power. I'm going to be skipping around here. Let's look at this example right here. So on this one, you have multiple terms inside the parentheses, but you do everything the same. You're just going to take the 3 and you're going to multiply it to every power inside the parentheses. So you do 3 times 5, which gives you 15. And then you do 2 times 3, which gives you 6. So the correct answer would be 3 to the 15th power and y to the 6th power. So just remember, when you're doing power to a power, you multiply everything in the parentheses by that. Let's do this section here where it's called power of a product. When you have something like this, notice you have the product inside the parentheses. It's very similar to power to a power. What you're going to do here is the 2 is to the 1st power, the 3 is to the 1st power. So you're going to multiply the 3 on the outside to every power on the inside. So that means that your answer would be 2 to the 3rd power times 3 to the 3rd power. That's how you do that. So if you look at the next example, you do 4 to the 1st power, 6 to the 1st power. You multiply the 4 to each of those powers. So that gives you 4 to the 4th power times 6 to the 4th power. You can also do it with variables. In the third example, you have the different variables. You have y to the 1st power, you have x to the 1st power. You multiply the 5 to each of those powers, which gives you x to the 5th power, and then y to the 5th power. So the key thing here is to don't forget to do all your terms. So like if you look at, let's skip down to, I'm gonna skip this one here. Look at this one here. If you notice, you have 2 terms. So make sure that you get the power for all the terms. It's 4 to the 1st power, x to the 2nd power. So the 1 and the 2 both get multiplied by 3. So this would actually be 4 to the 3rd power because of 3 times 1. and then you do 2 times 3, which gives you 6. So that would give you x to the 6th power. So make sure you multiply that 3 to all the powers on the inside. So 3 times 1 gives you 3. 3 times 2 gives you 6. So make sure you do that when you do power to a power. Let's see. I'm trying to make sure I go in an order that kind of makes sense, so it doesn't confuse you too much. Okay. Let's do the top part right here. Let's do this 0 exponents. I'm going to skip this part right here. The only thing I want to show you is this. If I have 2 to the 0 power, anything to the 0 power is equal to 1. It doesn't matter what number it is. If I do 5 to the 0 power, the answer is 1. If I do 10 to the 0 power, the answer is 1. Anything to the 0 power is always 1. If you don't believe me, put that in the calculator and you'll always get 1. Even if you have a variable to the 0 power, that's always going to give you 1. All right, so let's move to a different page. I'm not trying to, my goal for all these notes is to keep them short. I don't want to make them go too long. Let's do this one here, quotient of power. We've done power to a power, or when you're multiplying, you add your exponents. When you divide, you subtract your exponents. So they have to have the same base. So if I go back to these notes up here where we first started, where's it? It's right here. So if you recall, as long as they have the same base, you add the exponents. When you divide, you subtract as long as they have the same base. Notice that they both have the base of 2. So you're going to subtract top minus the bottom. So this would just be 3 minus 2 gives you 1. So the answer is just 2 to the 1st power. On this one, they have the same base. You do 7 minus 4, which gives you 3 to the 3rd power. On the next one, you do top to bottom. You do 10 minus 4, which gives you, which gives you 6. Now, when you look at the next example, there's a lot going on here. You just stick with the bases, all right? So the 5 and 5, you're going to do 12 minus 7, which gives you 5. So it's going to be 5 to the 5th power. For your y's, you stick to the 20 and the 8. So you do 20 minus 8, which gives you 12. So it's going to be y to the 12th power. Sorry, it keeps doing that. My hand keeps touching the keyboard. But where were we? I lost it. Oh, right. So this would be y to the 12th power, and then that gives you the answer to that. Now let's do, I know this is a lot of information, guys, but this was actually done over about 4 days. So again, but hopefully you've already seen it, so you these are semi-familiar with the information. If you have a fraction, you kind of do the same thing with power to a power. You put 1 here, and you just multiply the 4 to both of those 1s. So this would be 2 to the 4th power and 3 to the 4th power. If you do this one here, you put 3 to the 1st power, 5 to the 1st power, and you just multiply both 1s by 6. So that would be 3 to the 6th power divided by 5 to the 6th power. So pretty easy, pretty straightforward. Something more complicated like this, make sure there's 3 terms in here. The 2 goes to the 1st power, the x goes to the 1st power, and the y and the 9 goes to the 1st power. So all 3 of those get to the power of 3. So this would be 2 to the 3rd power, x to the 3rd power, and then 9 to the 3rd power. That doesn't look like a 3rd power. Let me do that again. A 9 to the 3rd power. And then the last thing I need to cover on here is negative exponents, I believe. Let me see. Yeah, it is. So negative exponents just means that we've kind of already talked about this. When you're dividing, you subtract the exponents. You do top to bottom. The only thing here is you're going to have a negative answer. You're going to ignore the top, just kind of follow my instruction. You're going to do 2 minus 5. So if I do 2 minus 5, that gives you a negative number. So that's equal to 2 to the negative 3. If you get a negative exponent, I want you to write it as a fraction. This is the same thing as 1 over 2 to the power of 3. This example here, this would be x, and you do 4 minus 6. This gives you x to the negative 2. If it's negative, you write it as a fraction. So it's going to be 1 over x squared. The next example, you're going to do 4 minus 9, which is going to give you a to the negative 5th, which is equal to 1 over negative 5. And notice that your negative exponent goes away. And then on the next one, just stick with the correct bases. So you're going to do 4 minus 9, which gives you a to the negative 5. And you do 5 minus 12, which is going to give you b to the negative 7. I don't want negative exponents, so rewrite it that they're positive. So you just write it as a fraction. So you just put everything over 1, or 1 goes on top. And that gives you the answer. You're about to get rid of the negatives. For this example here, we're going to subtract 3 and 7. So that gives us x to the negative 4. But the y is positive. The y doesn't have anything to get rid of. If it's a negative exponent, it goes in the denominator. If it's positive, it goes in the numerator. So the answer is y over x to the 4th. Okay, guys, that concludes your notes for laws of exponents. Make sure you take a picture of the notes that you take. You can always pause the video. I know that was a lot of information. If you need any help, please ask for tutoring and I will be there to help you. All right, guys, so again, make sure you take a picture of your notes and submit it in the Google Classroom.